So you need a battery charger for your next design. Well, first things first, we need it to work. Yeah, sounds simple, right? Well, it's not as simple as you may think. Choosing the right battery charger for your next design has a lot to do with the chemistry of the battery, the specifications of the battery pack, the communication protocols needed for your design, the safety features required, and a whole lot more. Why is "we just need it to work" so complicated? Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Thrax Cui from Meanwell and I explore how you can choose the right battery charger for your next design. We investigate the battery charging principles of lithium ion and lead acid batteries, the steps involved in choosing a battery charger, and how Meanwell battery charging solutions support the charging needs of a wide variety of applications. And before we get started, don't forget to click that link. There you can find even more information about this topic from Meanwell. Hi, Thrax. Thank you so much for joining me.
Hi, Amelia. It's my pleasure to join you.
Excellent. Okay, so we're talking about choosing the right battery charger today. But Thrax, first, what all will we be covering today?
So, what we're talking about today, we'll start with battery charging principles, and then we'll move on to the main course of today. We'll be choosing the right charger for your battery. Then we'll share some of the success stories of Meanwell's past projects. And lastly, we'll talk about how Meanwell as well as Mouser can help you with your charging needs.
Excellent. Okay, so Thrax, talk to me about that first bullet point you mentioned, battery charging principles. We're talking about a variety of different types of batteries, right?
That is correct. For the battery types out there are two types that will be our focus today. First will be the lithium ion batteries, which also includes the very popular lithium ion phosphate batteries. The second type we'll be talking about today will be the lead acid batteries, which is very common in your cars as well as in some of the lower cost battery applications. Non-chargeable batteries are obviously not going to be included in today's charger topic, like alkaline batteries or lithium metal batteries. Other batteries that need specialty chargers, like the nickel-based batteries, are not in today's topic either.
Fantastic. Now, Thrax, do the two types of batteries require different charging methods?
Indeed. As a matter of fact, it's quite dangerous and unsafe to utilize different or wrong charging mechanism for lithium-ion batteries, more specifically. That's where we're going to start with lithium-ion batteries. We should use a two-stage charging mechanism for lithium-ion batteries. First stage will be constant current stage, which I personally would like to call it max speed stage. At the beginning of this stage, we see that the charge current is already at the maximum level, which is our constant current level as well. You see the charging voltage as the battery being charged, the voltage increases, but the current stays the same at the max level. Once we reach the max voltage, then we will go into stage 2, constant voltage stage. On the graph, you can see the voltage doesn't change anymore because it's already reached its maximum level. The current, on the other hand, is dropping, and this will be able to help us safely charge the battery to full. Once the voltage is still the maximum, but the current dropped to about 10% of your max charging speed, we cut off. That is point where we determine, okay, the battery is full. For lithium-ion batteries, we'll just cut the battery off from the charger, and that is full charged.
All right, so what about lead acid batteries?
It's actually quite similar. The first two stages are exactly the same. We have constant current stage, which is maximum charging speed. We have constant voltage stage, which have the current gradually go down to about 10% of the maximum charging. But the difference is in the third stage. It's called float. In this stage, we have the voltage drop down a bit so that the charging current is at a very minimum level. We also call it drip charging. like a water faucet that's dripping, dripping, dripping. The same concept here. We have the charger keep feeding the battery a very small amount of charge so that will combat the lead acid battery's self-discharge problem. We do not use that to lithium-ion batteries because this will damage the battery and potentially cause fire hazards. Knowing all that, how do we choose the right charger? We want to make sure that the charger of choice is suitable for lead acid batteries or lithium-ion battery depending on your application. With meanwhile, majority of our chargers support both. But do keep in mind, you may need to change the setting on the battery using a dip switch or maybe using CAN bus and Modbus communication protocols to change the charging scheme. With meanwhile chargers, we have various type of different chargers. We have the external ones like the charge adapters or desktop type of chargers ranging from 30 watts to 360 watt. We have larger screw-mounted enclosed type chargers ranging from 450 watt to 3,200 watts. We have DIN rail chargers that's suitable for applications like industrial automation or control cabinets ranging from 40 watt to 480 watt. And lastly, we have larger, more specialty case chargers that you can put it on server racks ranging from 2,200 watts to 5,000 watts.
All right. So, Thrax, that's good to know. But how do we choose the right chargers?
We want to choose our chargers start from the battery side. For example, this is a specification sheet of a lithium iron phosphate battery. With that chemistry of the battery, we know we are looking for a charger that supports two-stage charging, or if the charger states it is capable or it's suitable for lithium-ion batteries. Now, a simple formula here would be we want to find the correct power for this type of battery. And we know power equals voltage times current. From the spec sheet, we can easily read the nominal voltage of this battery is 12.8 volt. The recommended charge current is 50 amp, and then the maximum charge current would be 100 amp. We put that in there, 12.8 volt times 50 amp equals 640 watts. However, as we all know, we need to have the charger at a higher voltage than the battery in order for electricity to flow into the battery. We can find on the spec sheet the maximum charging voltage will be 14.6 volt. We want to use that number instead of the 12.8 to get more accurate estimation of the power from the charger side. 14.6 volt times 50 amp, we get 730 watts. And for the upper limit, we'll be utilizing the max charging current, 100 amp, which we get 1460 watt. Going back to the page where we have all the different charger variants from Mingwell, now we have a target. We're trying to find a charger that is capable of outputting 730 watt to 1460 watt, and we need 12 volt for that. Out of all the options we see, the most suitable will be the NPB series. Here we have the NPB series spec sheet for both the 750 as well as the 1700, and we'll compare that with what we just calculated from the battery side. We always want to do double check before we choose the charger. Here on the NPB spec sheet, it was told that it is suitable for lead acid battery as well as lithium-ion batteries, which is exactly what we're looking for. This is a LFP battery that requires two-stage charging. Then we'll compare the voltage, 14.6 volt maximum versus on the battery charger side, 14.4 volt, which is slightly lower than the maximum voltage the battery can support, and still close enough that will be able to support fast charging. The amperage side, we're looking for somewhere between 50 amp to 100 amp. If the customer is looking for charging that is safer, the 750 will be the way to go. The 750 is able to do 43 amp. Or if the customer is looking for faster charging, the 1700, which outputs 85 amp for the battery, will be a great option.
All right. So, Thrax, what about sealed lead acid batteries? How would you go about choosing a charger for those kinds of batteries?
For cell lead acid batteries, the same formula stands. Power equals voltage times current. Now, we go to the cell lead acid batteries specification sheet. If you're able to find voltage, if you're able to find current, it'll be the same steps. However, there are some manufacturers out there, they have specification sheet in a different format. For example, in the screen, we have a 12 volt, 7 amp hour lead acid batteries. Now, you may wonder, okay, I understand this 12 volt. What is this 7 amp hour thing? How do I convert the 7 amp hour into the amperage I'm looking for? There is a different or another formula we should use in this scenario would be we can calculate the current by multiplying the battery's capacity with its rated charging speed. We call it C rate. From the same battery manufacturer's document, we can find that it recommends charging speed not exceeding 0.3 times C. Here the C is talking about the capacity. So we put that number in, 7 amp hour times 0.3. Now we know the charging current we're looking for would be 2.1 amp. Putting that with the nominal voltage of 12 volt, the estimation would be 25 watts for the required power from the charger side. From the previous example, we know that using the nominal voltage is actually putting the estimation of power on the lower end. You can dig deeper to find that charging this 12 volt battery, we should use somewhere from 14.1 to 14.7 volt. Putting the 14.7 in, we get the power we're looking for would be 31 watt from the charger. Now with that information, going back to all the Meanwhile charger off-the-shelf options, 31 watt 12 volt, we'll be looking at the GC series, which have a 30 watt option. Looking at the GC series spec sheet, it's clearly stated that it's suitable for lead acid batteries, which is exactly what we're looking for. On the voltage side, 14.7 versus 14.3, perfect. 2.1 amp versus 2.09 amp, exactly what we're looking for. So with that, we know the GC series is indeed a good option for this 12 volt, 7 amp hour battery.
Great. Now, Thrax, walk me through the main steps that we should keep in mind when choosing a battery charger.
In total, we should do 3 steps. First, using the battery's chemistry to determine the charging mechanism. If it is lithium-ion battery, we use 2-stage charging, no float. If it's lead-acid battery, we use 3-stage charging, which have the float stage. Then we'll calculate the voltage as well as amperage of the entire battery pack. Regardless of how many batteries you have, if you are parallel or serial connecting them together, from the perspective of a charger selection, you want to see the entire battery pack. Using the voltage and the current, you'll get the power we're looking for on the charger side. In the case where current is not readily available on the battery spec sheet, you may need to use the capacity of the battery and multiply that with the C rate to find the current. Once you have all that information, now you can move on and choose your charger. First, what type of charger you're looking for. If you're looking for external charger, like adapter type, a desktop type, or if you're looking for chargers that go into your product, like the screwed in enclosed type charger, or if you're looking for industrial automation like the DIN-rail type of chargers and whatnot, that determines the type of charger. From there, you want to move on to use the power you just calculated to find the correct series, use your voltage to choose the variant, and then lastly, double check with your battery specification to make sure this charger is safe to use. There are other considerations in terms of choosing a charger, like communication protocols, the safety features, the certifications. Those are the same as you choose any power supplies, so we'll not dig deep into those today.
All right. So, Thrax, can you share some real-life applications that Meanwell has worked on here?
Yes. For the lead-acid batteries, we did a project with a electric wheelchair scooter company. that they're looking for chargers that's capable of powering their 24-volt, 75 amp hour battery. From the specification sheet of the battery, they can only do 0.2 C. Multiply all of them together, we get 360 watt, which will be what we're looking for on the charger side. The customer ended up using our recommendation, MPB 360-24, which is an external type of charger that is outputting 360 watt at 24 volt.
So, Thrax, what about lithium-ion batteries? What kind of applications are we talking about here?
For lithium-ion batteries, very common application would be in the robotics. For example, one of the customers we worked on, they are looking for a charger for their 48 volt, 100 amp hour battery. And this battery, although it's capable of accepting much higher charging voltage, the customer wants to limit the charging current to 20 amp. Thus, we recommended an enclosed type charger of 1000 watt. In addition, they are also implementing this charging station in both indoor and outdoor applications. We chose two different chargers for that. For the indoor, we used the MPB series, which we've seen multiple times in today's presentation, which is one of our go-to chargers. For the outdoor applications, we chose the HEP series, which is fully weatherproof, that is capable of being utilized outside. The other applications we worked on as meanwhile is like the UPS applications. We used off-grid NTN5K. In the case of power outage, the NTN5K can work as a UPS and take DC power from batteries and invert that into AC output to power up the load, like your ATM machines, your vending machines, your household appliances. And the moment AC utility comes back, the NTN5K will be able to revert back to the charger mode and charge the batteries back to full and prepare for the next power outage when it's needed. This device can also be utilized in conjunction with other chargers like your solar MPPT charger or different chargers that you want to use for these batteries as well. Now, this is called an off-grid charger. That is because under no circumstance the NTN5K will provide AC power back to your grid. A different type would be OnGrid. We have the BIC series OnGrid charger for customers that needs vehicle-to-grid type of application, or if you're doing a lot of battery testing, this will be a great option. During charging state, the AC power goes into the BIC. The BIC will convert that to DC and charging your battery. When you want to drain the battery for testing purposes or for selling your DC power back to the grid, the BIC will use the same circuitry. You don't need to rewire anything. The DC power will come out from the battery, and then the BIC will send it back to the grid or send it back to other AC load that you may be connecting this to. Those will be the off-the-shelf products of Meanwhile chargers that you can use for. We also did a lot of custom-made applications. One example would be this warehouse robot charger. This one requires 19 kilowatts for each unit. This charger is used for a warehouse robotic arm, and it requires 480 volt AC 3-phase input and 58 volt DC 330 amp output. No off-the-shelf product from any manufacturer is able to do this. That's why we decided to custom made for this customer. Customer also needs UL 1564, which is the UL requirements or UL standards for industrial battery chargers, and FCC Part 15. The design requires to be IP52. It needs to be a seamless design so that it can have multiple inputs side by side, and they require CAN bus communication. For the charger of choice, we actually decided to go with the SHP10K. This is not a typical charger. It is categorized as a power supply. Meanwhile, as a power supply manufacturer, we are able to change most of our power supplies to be a charger. This way, we're expanding the possibilities of our charging offering to meet your needs. With 3 of the SHP10K, we will beyond the required 19 kilowatt power requirements. And then we design the housing from scratch. We design the entire enclosure, front panel, back panel, the top, the base, and we design the internal, including the frame, the shelf, the bar spar. In order to meet the UL as well as FCC certification, we build a prototype and we send it to the lab for testing. We blast it with electromagnetic interference, and we added the EMI filter for FCC, and we changed the housing design and material to meet the UL 1564. Once we have the certification and a OK from our customer, we started assembly and burn-in process. Burn-in means every Meanwell product we ship out, we already tested in our warehouse with full load for 24 hours that is functioning reliably. We built a 20 kilowatt energy recycling burn-in system specifically for this charger, and we burned in 2 full days. And then we did assembly SOP and provided documentation for our customer as well as our installation team.
That's super cool. All right. So, Thrax, how can my audience reach out for their charging needs?
They can reach out to Meanwell as well as to Mouser. We got your back. For Meanwell, we have vast selection of off-the-shelf products ranging from 1 watt to 30 kilowatt of standard power supplies. We can even parallel them up to reach half a megawatt. All of these products are available to order from Mouser.com. You want to follow Mouser for new product introduction information. If you have any customized needs, like the warehouse robotic charger we just shared, that you're not able to find any off-the-shelf solution out there, reach out to Mouser, reach out to Meanwell. We have Power Solution Team, which will be able to help you and customizedly build your solution from scratch.
Fantastic. Well, Thrax, I think that's all I have time for today. Thank you so much for joining me.
Thank you, Amelia. It was my pleasure, and looking forward to see you guys next time.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Meanwell. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.